Well, let's have some more fun with Excel, shall we? So what we're going to do is explore the Spiral Kinematics Activity, page number 20, and that's one where you've got an elevator moving downward at 4 meters per second. When somebody presses the emergency stop button, the elevator comes to rest after traveling 2.9 meters. And so you can set this up a variety of ways that if you've looked at the pencast that I did of the solution, you'll know that I put the origin with up as positive and at the place where it came to rest. So that meant that the initial position was 2.9 meters and the final position is 0. And that means that the velocity is a negative 4 meters per second since I chose up as down and they were moving down. Excuse me, up as positive and they're moving down, so that makes it negative. I should make this, hello, 2.9. That's where we started out. So what I'm going to do with this is a couple of things. First of all, I'm going to show you how you can set this up to be a second order numeric model that the first one that I showed you wasn't as accurate because it assumed that the acceleration was not, that the velocity wasn't changing in each of the time intervals. If you choose a small enough time interval like we do in VPython, that ends up being a fine model. At a more granular level, with a larger grain, like zero point 0.1 seconds, it can come into play. And so I'll show you how we can go ahead and average it. I'm also going to show you how you can use this to solve problems if you don't know the answer. But then you can also use it to check answers. And so what we need to do is enter in the initial information. And so I chose a time step of 0.1 seconds because I figured that this is probably going to take a couple of seconds, between 1 and 2 seconds. So I've gone ahead and chosen to have the time run for 1.5 seconds. And I've put in my initial position and velocity. At this point in time, I don't know the acceleration and I don't know how long this is going to last. So what I'll do is I'm going to go ahead and write the equation for velocity. And so the equation is equals, so my velocity in the future is equal to my velocity in the past. So I click on the cell above, and then to that, I'm going to add the acceleration, which is going to be the cell next to it, times the time step. And so the time step here is 0.1. Now, some people would prefer to not type in the number. So what they would do is just like we do in spiral kinematics. They would put a parenthesis and say, well, this is time 2. And from that, I'm going to subtract time 1. And so, that's the way, I guess, it's more pristine. And then what I'm going to do is I'll copy that on down. And needless to say, since I don't have any acceleration going on right now, that it's not a big surprise that I'm going to end up with the same velocity the entire time. Now, for my position in the future, it's going to equal my position in the past. So I'll click on that, plus the velocity. Now, what I had you do in the past is I had you just click on the cell next to it. But if there is an acceleration, the velocity is not the same throughout the time interval. So an easy way to deal with that is to average the two velocities. And so you remember how to do an average of two numbers, right? What you're going to do is you're going to take one velocity, add the other velocity, and then you're going to divide by 2. And so that gives me the velocity. Now what I need to do is multiply that. So let me multiply. And then what I'm going to do is, let's do that time deal again. So it's going to be time 2 minus time 1. And I'm trying to see where I made the mistake. No, that's not right. Okay, so let me do that again because I wanted A4 minus A3, not A30. Let me pause a moment. I think we're good. So I'm going to go ahead and copy that on down. And clearly, this is not an accurate model because there's no acceleration. And you see that I come to a rest between, or get to the zero position, I shouldn't say rest, at somewhere between zero 0.7 and zero 0.8 seconds. And I know that this is something that um, that's probably, well, because what I need to be able to do is to have a velocity that comes to zero. And so what I'm going to do is just, I'm going to start making guesses about acceleration. Now, if I'm moving down and I'm slowing down, if I'm moving in the negative direction slowing down, that means I must have a positive acceleration. And so we don't know what the acceleration is. And so, what we could do is we could just start with 1, and then let's copy that down and see if that models, I said, let's copy that down and see if that gives us anything. And what I see is that I have not come to a rest yet by the time that I have, traveled, because it's at this point that I should be coming to a stop, and I'm quite a ways away from that. And so what I'm going to do is I'm going to change this number, and what increments you change in is kind of up to you. I'm going to do 3 because I thought I was significantly off. And I look here, and it looks like I'm slowing down a little too much because I reach a zero velocity before I've reached the ground. So let me try, I could try 2.5, or how about 2.75? And I'll copy that down. And you see that I come to a rest and a stop somewhere pretty close. It's not exact. And so, if I wanted to, I could fiddle with this to get more of an exact. Like, I think when I did the calculation, that it was actually 2.76. Not sure that that will show up on here to be a significant, but if I do that, what I find is that I'm pretty close to the answer that I calculated as being 1.45 seconds. So this is pretty close. If you look in this interval, that's pretty close to coming to zero in terms of position and zero in terms of velocity. One of the other things that you might want to be able to do is to draw graphs. And to do that, you can highlight the time and the position, for example, and then what you're able to do, and I'm trying to see if I can see it where you can see it, charts, there we go. And the sort of charts we use in physics for this sort of thing are scatter charts, and I usually use smooth marked scatter just because I can, and I hope that that makes sense to you. And it's easy to go in, I said it's easy to go in and change stuff, add units and descriptions for the axes, etc. If you want to do, oops, come on. If you want to do columns that are not next to each other, that what you can do is hold down the command key if you're on a Mac, and then I believe that if you do it with right clicks, you can do it on a PC. But if I wanted velocity versus time, then I need to select the time and then the velocity. And again, I could add a scatter to it, and I hope that looks as you would expect it to. So I hope that you can see how to use Excel to add that average velocity piece in to make it more accurate, how you can use it for problem solving, and then you can use it to actually confirm numbers that you got for the algebraic model that you have, and then how you can make graphs.